Well, welcome everybody. Thanks for joining us this afternoon. So my name's Dave Linville. I'm a Chem-E from Ohio State, and I've lived in Georgia long enough to realize that I can't say that without also saying we can all hate Alabama together. So I've traveled a lot around the world in the last couple years, talking to a lot of water systems, and two things always come through in the conversations. One is it's really tough to find and retain people, and two is all that they want to do is make the absolute best quality water for their customers. That seems to be the case just about every place that I go, just about everybody I talk to. So my belief is those things are best accomplished by basically coming up and setting some core values, communicating those, and living by those. And so our core value is relatively simple. It's this. We believe that everybody deserves clean water. And so the way that we believe that's best accomplished is through innovation and teamwork. And so in that spirit, we invited some of our friends to join us and sort of talk about their perspectives on innovation in water. We've got Frank Slovenik, the co-executive director of Global Waterworks. We've got Damian Luna, the principal engineer for Albuquerque Bernalillo Water Authority. And we've got John Nielsen, the administrator for DeSoto Waterworks. So Frank, what are the issues being discussed in your community?
So Global Waterworks, like it says, is global. We're in 94 countries and every state in the U.S. So there are three major topics that are being discussed to the highest degree. The first one is harmful algae blooms. Certainly it's an issue. EPA pointed out in a report about 6 months ago that's an issue in all 50 states. And then just recently, the GAO came out with a report putting together a work group in the government to address harmful algae blooms. So not only monitoring and researching, but from our perspective, we're looking at preventing and remediating. Number two, right along with what the gentleman from Mueller said this morning, is cybersecurity. And that's a global issue because you have so many endpoints in your business, whether it's handhelds by employees or whether it's smart meters at the home. There's so many entry points that are at risk for cybersecurity. Then the third thing that people are talking about, and I think you can understand a lot of reasons for this, is point of use water. Water filters at the home, water filters in the business. We all understand the infrastructure challenge. We also understand there's thousands of miles of pipe in the last mile delivering water that's has lead. PFAS is an issue, and certainly pharmaceuticals along with other metals and other chemicals that are issues. So point of use water filters and filtering water at the home and at the business is a key topic of discussion.
All right. Excuse me. So Damian, what are some of the lessons learned as a large system with seasonally changing source water?
So, living in an arid environment, and we faced some challenges just recently, past 3 years. We had record drought. One of the issues with drought is that a surface water system such as ours can no longer pull water from the river. So we were mandated at one point to shut down our facility, and one of the lessons learned is during a period of shutdown for 3 months, it has some unintended impacts to our surface water treatment because it's a long-term duration shutdown. And so we had to, at startup, had some issues with water quality, and we had to learn how to deal with that situation. So what we did was we took a very good look at some of the impacts and how to plan for it in the future because we knew that drought wasn't going away. And so we had two more seasons after that where we implemented some strategies on how to protect our surface water treatment plant from those water quality issues. And I think it's always just an approach of lessons learned, how to take those lessons, implement them into SOPs, and how to deal with it in the future. And we were successful. So the lessons we learned during the first long-term shutdown, we applied. And when we had startup at the second season, we no longer saw those water quality issues. And again, it's taking what you know at that time and applying it to the future.
All right. So John, what are some of the operational challenges that you've overcome to be able to deliver great water to your customers?
Well, our system, we actually produce twice as much water as our plant was originally designed for. And when your production exceeds your capacity, it can lead to a degradation of your quality. And that not only goes for a physical water plant, but also for each individual in here. I compare the human body to a water plant, and a water plant has a personality. If you don't think a water plant has a personality, you have never operated a water plant, okay? Two water plants side by side using the same water can work entirely differently. So if you're working 10 hours a day for 7 days a week, your production has exceeded your capacity. Same thing with your water plant, okay? And I'm an old guy, so I watch Gunsmoke all the time and all the old cowboy shows, and if you do that, most of the advertisements on there are going to be for some kind of vitamins or something to help your body. And so they tell you all these good things, and all of a sudden then they have all these side effects that can come along. And you listen to some of these side effects and you say, why in the world would I want to take that medicine, okay? Well, when you have a water plant that's stressed, you have to think of the same thing in the term of chemicals. Okay, you might inject a chemical into your water plant that does one thing, but all of a sudden you're going to have a side effect somewhere else in a plant that's stressed like that. And a prime example of that is in Louisiana. Our chlorine residual went up by 2.5 times a couple of years ago when we had an amoeba outbreak. And all of a sudden the health department says you've got to have more chlorine in your water system. And that was the end of their sentence, okay? The result of that was all of a sudden we had trouble with DBPs. So you have one thing, but you have a side result of that. So that's especially true when you have a plant that's stressed as much as ours is. We're in the process of enlarging our plant by twofold, so it'll be a lot better. But that's some of the things you have to think about. That water plant is an organism, and if you push it past its limit, then you are going to have some individual stresses on that thing that may not can be overcome with just a normal chemical. You want to look at a chemical that maybe does two things, and you have to look at what it's doing at the plant, what's it going to do out in the field with a huge distribution system like we have, what's going to be the end result of it over there. So you have to think long-term and long effect for everything you do in a plant.
John, what do you think are some issues that currently are not getting enough attention within the industry?
Well, there's going to be more attention on it more and more, but the secondary standards, we just really haven't paid enough attention to those. We have, you may have a discoloration in your water. That's a secondary standard. You won't get wrote up for it, but you'll sure get a lot of comments on Facebook and everything about it, won't you? Okay? So if you can get rid of those, I think we need more and more attention on these secondary standards, taste and odor, and because they're coming to be primary standards before long. And fortunately, some of the government agencies are putting some money into that to help us with those things. But we really need to pay more attention to those secondary standards, because somebody is waiting in a big office somewhere to press a button, and all of a sudden they're going from secondary standards to primary standards, and we're going to have to meet those standards.
Damien, you just keep it going down. Yeah. Same question to you.
I would say for a lot of communities, water conservation is huge right now. I don't think that a lot of people thought that climate change would be so fast and significant as it is right now. I know that our water system has a water conservation plan that's been really successful over the last couple of years, Water 2120. And so what that is a holistic approach to conserve what you have. Our aquifer was, years ago, was depleting. So Water 2120 took that into account. How could we recharge our aquifer so that it was no longer depleting? The other goal was to not acquire any more water rights to address the issue. We wanted to use what we had, so again, we took the surface water treatment facility and started recharging the aquifer through ASR. Aquifer storage and recovery. We started banking water using the existing aquifer that we had by taking the water we produced at our surface water treatment plant and putting it back in. We're testing those wells right now to produce water. I've been monitoring emails, and we're pulling successfully that water that we banked and putting it back into our system to supplement this period of high drought. So.
Yep. Same for you, Frank.
So there's two things that I think that we could talk about. The first one is connecting people with their water. All the great work that you do in your utilities, not enough people know about it because they're not connected to the water. It's free, and they turn on their faucet, and it's there, right? So we believe in education, and we've launched an education program to start actually we're going to start it in Sunday schools, is teaching children about their water. The water cycle, what goes on with the water. I live in Hartwell, Georgia, a small community, Hart County, and the director of Public Works is going to be involved with us there, and then this is going to go national. So connecting people with their water through education, understanding the cycle, where it comes from, and all the fine work that's done by water utility professionals across the world. The second thing, and it was touched on a little bit earlier this morning, is water workforce development. Water is, we are working very hard with a number of organizations, partnering with them, to bring the next generation into water. What is not known out there is you are probably in the most exciting industry on the planet. You affect society, you affect healthcare. Many water workers call themselves healthcare professionals. You are. Health is in water. And so and economics. I live on Lake Hartwell. Let me tell you, something happens to that lake, economically, it hurts. Something happens, and you hear Flint, Michigan, or whatever, it's an economic disaster. So it is so important that people get connected with their water, and then two, bringing the next generation in and understanding what an exciting field it is for them to have a full and very, very rewarding career. I'm working hard to do that.
Thank you. So appreciate that, gentlemen. I think that was very interesting perspectives. Thank you very much. So at Aquasmart, we think it's very interesting that the transmission of water has been around for a really, really long time. I think somebody this morning, gave a little bit of a history lesson on water and the Romans, and I just think that's so interesting because we have the exact same view. And what we find interesting is the problems that the Romans faced are the same problems that we face today. How to not have corrosion, how to not have scale, how to not have bacteria. And what we find very interesting, and hopefully you all will find a little bit interesting next, is we've done a lot of work over in the UK where we believe a future glimpse towards some of our future potential problems may lie. And there might be something to be learned from that. So you couldn't have said it any better, John. I always like this picture because every science fiction movie begins the same way. Man messes with nature and then ... And so the idea of cause and effect is something that's very, very important to the water industry and something that we believe there could be some additional focus put on. And there's been much discussions about the revisions to the lead copper rule. If anybody wants to talk about that, come find us in our booth. We're not going to talk about that today. I'm sure you've seen a lot of PowerPoints about that over the last year and a half. But what I would venture to guess is that this sentence is probably not one that you've seen before, which is the idea of looking at things holistically, potentially might be a good idea. So what does that mean? What we're going to do now is the fun part. So rather than continue with PowerPoint, we thought now it's time to open up the boxes and we can talk about chemistry. We could do some experiments. So let's pull this around. So what we're going to talk about is the link between corrosion and sequestering and some of these other issues. So what you've got in those bottles is everybody should have 2 bottles of water, 2 little powder pillows of ferric sulfate, which is iron. You've got a little vial of chlorine, which is the white top, 12.5% bleach, and you've got some SeaQuest, which is the product that Aquasmart makes in the black top. So the first thing we're going to do is take one of the bottles of water and take one of the powder pillows of iron and dump it in there and shake it up. There you go. Yeah, give it a good shake. There you go. What do you guys think is going to happen? Turn brown? Yeah, maybe. Yeah, maybe. There you go. All right. All right, you getting a little bit of color to it? Maybe a slight tinge? Okay. So the next thing that you're going to do is you're going to take the bleach. So take the little bottle that has the white cap and sprinkle in a couple drops of bleach into that same bottle that you just put the iron into. However many you want. What do you guys see? Yeah, it's yellow, right? Nobody got purple, right? So what's happening here? Anybody have any ideas? We got any other chemistry people in the audience? Let's hear it, Chris. Little oxidation. There you go. So that's what oxidation does. So if you've got iron, the first form of iron is soluble. And then when you oxidize it, you make it insoluble. And so in the spirit of the holistic comments that we were talking about earlier, that has 2 impacts on your ability to deliver clean water to your customer. One of them is relatively clear, which is nobody wants to drink water that looks like that. The second is a little bit more complex. Any ideas on the second one? Of what effect does oxidizing iron have? Don't do your laundry? Yep, absolutely. What's the reason that you use bleach? Is it to oxidize iron? It's to kill bacteria. So you just used it to oxidize iron, and now you're going to need more of it to kill bacteria. So if you ran a free chlorine test on that bottle, it wouldn't be what you want, because there's no free chlorine left over. All right, so now take the other bottle of water, I should say. And first, the little black vial, or the black top vial that has the SeaQuest in it, go ahead and dump that in. Whole thing, just dump it in. And give that a good shake. All right. After that's nice and mixed, now go ahead and take your iron and put the iron in there. All right, give that a good shake, get that all nice and mixed up. And now go ahead and put the bleach in there and see what happens. So that's the process of sequestration. Basically, the idea is you keep iron soluble and prevent it from coming out of solution. What's interesting is what can happen is iron comes from 2 places. So the first place iron comes from is where? Like manganese.
Just naturally occurring.
Naturally occurring. So it can be naturally occurring. Maybe you're filtering it out. Maybe you've got some kind of oxidation filtration step. The second place is where? Pipes, corrosion. So what you see on the table, the 2 jars that have the pieces of metal sticking in them, what you see there is one jar that's got just water in it, and another jar that's got water plus SeaQuest in it. And we did this about an hour, 2 hours ago, and we'll keep watching those as the day goes on. And you can see the water without the SeaQuest in it probably has a little bit of a yellowish tinge to it, I would imagine. And so that shows corrosion of iron that then puts, or corrosion of mild steel that then puts iron into the water, that then you put chlorine in, and then you oxidize it, and then you have low residuals, and then. So what the SeaQuest is a holistic approach to corrosion control. And there's two ways to look at what we do. The first way is the traditional way, which is you've got categories of types of corrosion inhibitors on the left, and you've got the typical way that those are evaluated as the columns. So obviously, you have to work, controlling lead and copper. That's very clear. They should work controlling, steel. Maybe they should work, controlling color and appearance. And then, how much do you use and how much does it cost? And that's usually, the methodology that goes into selecting corrosion inhibitors. What we believe is really important is having a little bit more of a holistic view to this. And so looking at things like how much phosphorus is being put into the water, how much chlorine residuals are you able to generate? Do you form disinfection byproducts? Do you have to switch disinfection because you're forming disinfection byproducts? Maybe you have to go on chloramine in the summer. If you've got clogged up pipes, how does that impact electricity and water flow, pushing the same amount of water through clogged up pipes? Who's measuring that? Workplace EHS, right? How to hire, good people. Well, we were just talking about, don't expose them to really, really hazardous chemicals would be one way, to potentially help. And then, at the end of the day, total use cost. So we engineered SeaQuest to essentially address all of these issues. We've been doing it for a really long time. We've treated a little over 8 trillion gallons of water around the world. And we get a lot of letters back from our customers talking about how we've helped them, and these are some of the things that they say. And then most recently, this is sort of hot off the presses, we are in the process of completing a major year-long study to look back at the performance of SeaQuest versus other things over 20 years at our customers related to the lead numbers that they report to regulators. Because my personal belief is studies are very helpful, very important, but the ultimate test is what numbers get reported to the regulators. That's the ultimate test. And what we see here is on the left, customers that switched from a different mechanism to SeaQuest, their lead numbers went down. And then on the right, the customers that used SeaQuest over 20 years, their lead numbers went down. And in both cases, they're well within compliance of the future EPA limits of 10. So, hopefully you guys picked up on the DeLorean time machine in the slide at the beginning. And as promised, we can go back to the UK. And so we're doing a lot of work over in the UK now because they basically did what we are about to do in the US roughly 10 years ago. If anybody's interested, there was a paper around the Chesapeake water system presented in Virginia back 2015 that talked about the United Kingdom and what's happening with lead control, and that a significant amount of orthophosphate is going to be used for lead control in the UK, and there might be some downstream effects of that. Back to John's comments about unintended consequences. And so the UK is currently in that position now, and with the recent global supply chain challenges, they're especially in that position. And so what we thought we'd show here is basically what they're facing. They spend a lot of money on orthophosphate. It generates a significant amount of phosphorus that their wastewater treatment plants now are very much struggling to deal with, which is driving a massive increase in coagulant usage and a massive increase in sludge, which they then have to haul off, but they have no place to put it. And as an industry, they've committed to net neutral carbon footprint by 2030, and that's very difficult to achieve. And so it just shows a little bit of the potential here where hopefully we can help them in a lot of systems over there, basically use less phosphorus, reduce their carbon footprint, and eliminate red water complaints, change the residuals like we looked at in the test, and ultimately do that without any CapEx. So our mission is real simple. Like I said, it's everybody deserves clean water. And we would really appreciate your help. If there's anything that we can do to help you, please come find us. If you have need for more information, we've got some technical documents in that packet in front of you. You can come look on our website. There's a video that talks all about SeaQuest and how it works. You can find us in the showcase later today or tomorrow. Thank you to our esteemed colleagues up here who generated their time graciously. Appreciate all the time spent with you. Thank you very much.